The previous video focused on what it means to have a first ionization energy and the pattern for that. It generally goes up, and what a second or third or fourth ionization energy would be. Those increase 700 to 1400, 500 to 1800, 800 to 1600 for all of them. But hopefully, what you notice here is sometimes there's a big jump. Going from 15 to 26 to 39 to 57, that's increasing somewhat linearly. From 1,000 to 22 to 33 to 45 to 70, that's a more or less linear increase. And same idea, silicon, 7 or 800 to 1,500 to 32 to 34. We're adding about the same amount more energy each time, but then we've got a big jump. Or right here, we add about, excuse me, we add about 1,200. We add about that same amount again, but then we go way, way, way higher from 3,000 all the way up to almost 12,000. We double it, and then we go 5 times more, or we go up by 700, and then we go up by 6,000. The pattern for the biggest increase here is that it is right here, the removal of electrons. It is over here in blue, the inner shell electrons. The valence electrons have fairly low values. Sodium over here has just one valence electron. After we remove that, its next electron, the reason I didn't say valence in the previous video was that its next electron's in a lower, closer level that we'll look at right down here. The inner shell electrons become much harder to remove. Just like in the last video, I'll point out where I disappeared, but we've got the filled in versions here that I have this filled in. You don't have to just write down every word that I say, but it's those inner shell electrons because we're at the next closer level. So here on sodium versus magnesium, sodium has a low value for the first one. That's because it has just one valence electron and a Zeph of just one. Magnesium's a little bit smaller in size, a little bit higher Zeph, a little bit higher ionization energy for the first one. But after this guy is gone, boop, remove that guy for sodium. I'm covering it up. My next electron is in a lower level. It's a level closer, it's a ring closer, and it has less shielding. Now there's only one level in the way between the 11 protons and these next set of electrons I'm going to start to remove. So those are much closer with a much higher Zeph, much less shielding, and much more attraction. Whereas magnesium, I take away this first one. The next one is still out there in the third level. It's still pretty easy to take. But X this guy off, X this guy off. The next one is in the next lower level. The electron after the valence electron is the hardest to remove. Sodium has one electron. We have a big jump for the second. Silicon has 1, 2, 3, 4 valence electrons. They get harder and harder and harder, but it's the fifth one, the first one that isn't valence, where we move to a level that's closer. We have less shielding, we have more Zeph, we have much more attraction, and we have a big jump in ionization energy. So that's the key of what we're looking at here is when we go to the electron at a lower level, not a lower sublevel, or when we've removed all of our valence electrons, that we have that significantly harder electron to remove.